Hi everyone. So in this video, we will be solving the coding question of last year, 2025. The most hard question TCS asked last year. That question we are solving this video. Okay. And why this is a hard question, why I'm saying this, I'll just explain you. Okay. But this was the exact question which was asked in TCS last year. Okay, and we need to solve in 55 minutes in the compiler, so time was given enough. Okay, but the question was from a topic which generally TCS do not ask, that is graph. Okay, so this question is from graph. So TCS last year asked this question from graph. Okay, generally TCS never did ask the question from graph. Okay, but last year they did ask. Okay, so in this video we will be solving that. Before going ahead with it and explaining the question, I will just give you a very good idea. Like if you have your exam, okay, today we are going with one full live test. You can say here the full live test will be live today. Okay, this kind of test will be live today. You can see here from 3 p.m. only 28 minutes are left for this test. Okay, you can attempt this test, and many full length live tests are going on in which many students are attempting the full length test. Okay, and they are seeing their rank, like where they stand up from other students. Okay, this is the full length test, okay, with 65 questions, 65 minutes. Okay, so you can attempt it. It will help you a lot to determine your performance. Apart from this, we have given enough full length test for TCS. Also for practice set, you will be getting more than 800 question, or for coding we have provided the coding sheet with solution. Okay, so previous year questions with solution are there in this coding sheet. Okay, also previous year full MNC coding sheet is here, 367 pages with screenshots. Okay, so you can see the screenshots also from the companies, and you see here this is the screenshot of the actual question of the company. Okay, and the solutions. So we have worked a lot for this one. So definitely these all the things you will be getting in the mock test. The link will be in the description. Also full length test we are conducting, so a lot of things you will be getting at a very nominal price. The link will be in the description, which you can use for your practice. Now let's start with this question. Okay, so the question is saying Rohan works for a logistics company that delivers package across multiple cities. The company's delivery routes are represented as graph where each city is a node. Each route between these two cities has a travel time. Rohan need to find the minimum travel time from the main warehouse city's source to all other cities. Help Rohan write a program that given the number of cities, the list of roads with the travel times, and the source city calculate the shortest travel time to each city using Dijkstra algorithm. Okay, hence they have not mentioned the Dijkstra algorithm in the actual question. They just mentioned we need to determine the minimum time. Okay, so what this question is saying, suppose there are cities called A, B, C, D. Okay, so suppose this is city A, this is suppose city B, this is suppose CD, city C, and suppose this is city D. Now from A, Rohan is traveling to B. Okay, from B there is C. Okay, from B there is D, and from A there is D. Okay, suppose this is the connection. Then A, suppose A to B, if we travel A to B, it takes 1 hour. For B to D, it takes 2 hour. For B to C, it takes 2 hour. And for C to D, it takes 1 hour. For A to D, it takes 2.5 hour. Okay, now we need to determine, okay, if we are starting with A, if Rohan is starting with A, what is the minimum time to traveling to each city? So if he is starting from A, then traveling, if he is starting from A, then obviously the time will be 0 for A. So for A it is 0. For B, what is the minimum time? Only 1 hour and only one route. So for B, it will be 1. Okay, what will be the minimum time for B? Okay, so now calculate it. From A, it is 1, then 2, so it's 3. Okay, suppose we want to go through D, so it is 2.5 plus 1, it's 3.3. Then, okay, so these are the all paths. Okay, so we checked all the paths, and the shortest one is 1 and 2, which is 3. So till C, the minimum time is 3. Now reach to D. So first path is A, B, and D. So A, B, and D will give us 3 hours. A, B, C, D, it will give us 3 to 4 hours. Okay. And direct A to D, it will give us 2.5 hours. So minimum is 2.5. So our answer will be 0, 1, 3, and 2.5. So this we actually need to tell. Okay, so it's a Dijkstra algorithm question in which the ages is given and the time is given as the weight. Okay, so this we need to solve. Now let's, I hope you guys got this. Now the main thing is input. How TCS have given the input for this question. So this, they have given the input in ages format, ages. Okay, they have not provided the adjacency graph, they provided the ages. Okay, so adjacency list is given in the input. Okay, how they provided the input, let's see here. So first there is 5 and 6. 5 is the total number of nodes. Okay, total number of nodes, that means total number of cities. Okay, 6 is total number of ages. Ages means connection between the cities. Okay, ages. Okay, and that's how the ages are given. So 0, 1, 4 means from 0 to 1, the traveling time is 4 hours. From 0 to 2, from 0 to 2, sorry, the traveling time is 1 hour. From 2 to 1, from 2 to 1, okay, this one, 2 to 1, traveling time is 2 hours. From 1 to 3, from 1 to 3, okay, 1 to 3, the traveling time is 1 hour. Okay, then from 2 to 3, 2 to 3, the traveling time is 5 hour. Okay, then from 3 to 4, okay, suppose 3 to 4, so 3 to 4, okay, from 3 to 4 the traveling time is 3 hours. Okay, so 0, okay, 1, 2, 3, 4, 5, and the time is given here. Okay, we need to find out the expected output. From 0 to 0, obviously the time is 0 hours. Okay, now from 0 to city 1, okay, we want to travel to 0 to city 1. So 0 to 1, 4 hours here, and 1 hour and 2 hours here. So the minimum time is 0 to 1 to, how much time for 1? It's 3 hours. Okay, 1 and 2. Now, okay, 0 to 2, 1 hours. Only one path is there. So from for city 2, it's 1 hour. Now for city 3, it is 4 plus 1, which is 5. Then 1, 1 plus 5, okay, it's 6. 1 to 1, it's 4. Okay, so 1 to 1 is 4. So for 3, it is 4. Now for city 4, 5 plus 3, 8. 1 uh, 2, 3, 4, and then 3, then 7. So for 7 it is 4, for it is 4, it is 7 hours. Okay, so this will be our output. Okay, for city 0 it's 0, for city 1 it's 3, for 1. Okay, so this kind of input is given, this kind of output should be there, and at the last this 0 means from which city we are starting. Okay, so how will actually we will write the code? We will use Dijkstra algorithm. Okay, Dijkstra algorithm we always use for weighted graphs, right? We already know. So how will we use it? Okay, so basically we have the ages list, correct? Ages list. So we will start pushing the ages. Okay, we will start pushing the ages in min heap. Okay, and what the ages will contain? The source, okay, the source and the distance. Okay, so basically you can say the city, okay, city and distance. Okay, this the whole pair will carry. Okay, city and distance. So for each city and distance we will be calculating like that, from minimum heap. Okay, so how we will be doing it? Okay, so first of all, suppose we start with 0. Okay, so first of all we start with 0. So for 0, we will check the cities from which, for which we can go from 0. Okay, so we'll check here. So these are our cities. Where is our graph? This. So for 0 to 1, it is 4. Okay, so we'll just, for 0 to 1, we will just store 4. Okay, now for 0 to 2, it is 1. So we will store 0 to 2, it's 1. Okay, now again from 2 to 1, okay, from 2 to 1, it's 2. Okay, now from 2 to 1, 2 to 1, it's 2. Okay, first we will check what is the value in the front of 2. So in the front of 2 it is 1, because already to reach out to we are requiring 1 hour. Okay, so we will extract it. So we will say 1 plus, from 2 to reaching out to 1, it is taking 2 hours, so we will say 1 plus 2, which is 3. Okay, so at 3 hours we can reach to 1. Okay, now we will check 1. So in the front of 1 it is 4, because first when we determined through 0, so it was 4. So it is more than 3 hours, okay, which we got from here. That's why we will update here 3. Okay, we will update here 3, because from this path we got 3. Okay, let's understand it again. It will just make your whole question clear. So suppose we are currently talking about only this. Okay, 0 to 1 4, 0 to 2. Okay, 0 to 2, it's 1, and from 2 to 1 it's 2. Okay, so first suppose we traveled from 0 to 1. Okay, so we traveled from 0 to 1. So for 0 to 1 we have stored, at 1 we have stored 4. Okay, because if we want to reach to 1 it will take 4 hours. Okay, now from 0 to 2 it's 1. So in front of 2 we will store 1, because to reach out to we need 1 hour. Now from 2 to 1 we have another connection, so we will check for it. Okay, so 2 to 1 it is taking 2 hours, and in the front of 2 it is 1. Okay, so we will extract 1 from here. Okay, and what time it is taking? 2, so we will add that, so it is total 3. So total number of 3 hours it is taking to reaching out to 1. Now we'll check if it is less than what we already have. So in front of 1 we have 4, so we have 3 which is less than this. That's why we will update. So in the front of 1 it will be 3, and in front of 2 it will be 1. Okay, so that's how we will do for all the edges, all the graphs, and that's how we will solve this question. I hope this is clear to you. Okay, and also if you want to solve the previous year question for TCS, okay, and if you want to give full length test for mock for foundation section, advanced section, everything is available in our mock test. Also the full length mock tests are available here, so you can check it. Okay, let's solve our question with code. So this is the code. Okay, so basically first we need to take the input. How we are taking the input? So we created the total number of vertex, created the total number of edges. Okay, so first, because we want to take the input as 5 and 6, so 5 vertex and 6 edges, so we have taken the input as 5 and 6. Okay, now we created our vector. Okay, this is our edges adjacency list, and we are creating it at the size of v, like number of cities. Okay, now we are taking three inputs. First one, the source city. Second one, the destination city, and then wait means time for traveling it. Okay, so we are taking the input in this manner, like this matrix we want to take input. So first there is 0 1 4. So 0 1 4 is means source city is 0, destination city is 1, and travel is 4. Okay, so UVW. Okay, then we are pushing this in our youth column, because from 0 we wanted to establish the connection to the V. Also for same V we are establishing the same connection, because it's an undirected graph. So we will be inserting V comma W and U comma W for both. Okay, now in this, how we are inserting this, because we already created one pair, like for this one. Okay, so it is ADJ. Okay, if you guys can see here, ADJ. Okay, so this is the one. Okay, and in this ADJ we actually provided the type as PII. Okay, PII. So what is this PII, which is storing this U comma W? So it's basically a pair which we already created. So you can see here we already determined the pair. Okay, so it is int comma int type. Okay, in which we can store distance and node. So first we are storing the distance, then we are storing the node. Okay, so that's what we have given in the type. Okay, I hope this is clear. Now after this we are taking the source input as a source, at which point we need to start. Then we are passing it in our dirextra function, the number of cities, then adjacency list, and our source. Okay, now the main part. Okay, this is our Dijkstra algorithm. So first we have created our distance array, and this array will store the minimum distance between each city. Okay, then we initiated it with a distance to source 0. Okay, because obviously at whatever the point is, suppose we are starting with city 0, then the distance of city 0 will be 0 only because it is the starting point. Okay, then we created the priority queue. Okay, priority queue, and we are using here greater. That means we are creating the minimum priority queue, min heap, or you can say we created min heap, because if we create the min heap, then with the smallest value it will pop up first. Okay, so we will travel through the edges which have the smallest value. Okay, so that's why we have created the priority queue or min heap, because we want to always go with the shortest path. Okay, then we are pushing the source node here, so distance is 0 and the source node is src. Then till our priority queue is not empty, that means we will go through edges to edges. Till then we will be running our loops. So first we extracted the d is distance, which is the first one, and then we basically source node we are storing in u, and the distance we are storing in d. Okay, then we checked. Okay, so suppose at one point there can be multiple nodes. So okay, there can be multiple ways to actually reach out to the same point. Okay, that's what we have discussed, right? Because recently what we have discussed, okay, from 0 to 1 we have already reached, correct? From 0 to 1 we have already reached, but there are multiple ways to reach out to 1. So from 0 to 2 and 2 to 1 also we have reached. Okay, so we will check if the distance is greater than already the distance stored in the front of it, then we will simply ignore, because if the already the distance is minimum through which we are like reaching out to it, okay, then there is like no way, right, to actually calculate it again. Okay, so what I'm saying is, ki suppose it is 4 year, okay, 4 hours to travel from 0 to 1, and suppose from 2 to 1 it is 5 hours, so already the 5 hours are more, and in the one we have the traveling time as 4. Then why we will check it, why we will calculate it? Okay, if it is lesser, then only we will calculate it. Okay, that's why we are checking here. If the distance is already greater than, if the distance is already greater than the point which I have explained, then we will directly continue. Okay, because we don't need to check that point we already reached out, and it already has the minimum distance. Okay, so we will not check that. Okay, so that's what we are doing here. Okay, so then after it, okay, after it we will go through the edges. Okay, after it we will go through the edges if it is not. Okay, so how we will go to the edges? We will just go with the automatic loop. Okay, we will extract the first stage. Okay, we will extract the first stage, and we will basically go with the second edge. Okay, so we will just extract the both values, the weight and the vertex. Okay, so for both we will extract the value. Okay, then again we will check what we have done here. Okay, what we have done here, just see this carefully. The distance of you, suppose we are at, understand like this way. Okay, so suppose we are on this point which is 2. Okay, just listen me carefully. We are at 2. Okay, again I am repeating, we are at 2. Okay, so for distance to 2 it is 1, correct? So first we are checking it. Okay, first we are checking it here. So that distance plus whatever the weight, so suppose the weight is 2 here to reach out to 1. Okay, so this one at point which we already have, so suppose we are at 2, so we are extracting the value of 2, that it has the time a minimum time as 1. Okay, then the weight, suppose the weight is 2 to reach out to 1, is lesser than the already put it weight on 1. So dist of v, okay, so we are just adding it what I have explained you. So distance of u plus the weight is lesser than the distance of v at the vertex which we want to travel. Okay, if the distance is less than it, then we will just update the distance with the new one. Okay, so we are just updating the distance with the new one, which is dist of u plus w. Okay, and then we are again pushing that the basic node with with the updated distance and the node. Okay, so this we are doing. After it we will just pop out our distance array in which we are storing the minimum distance for each and every point, and we are updating it accordingly. Okay, so after that we will be just putting out the loop and we will updating it. Okay, so this will be the whole idea of solving this question. Okay, I know maybe this will sound difficult for you if you do not have any knowledge of graphs. Okay, so but if you already know basics about graph, then I don't think it will be looking difficult to you. It is a standard question, it is a very standard question. So that's what TCS asked last year. It was the only question from graph for last year. Okay, so first time they did ask the question from graph, so that's why I solved it. Okay, thank you so much for watching.